Good afternoon, everyone. It gives me great pleasure to welcome you all to yet another webinar of Steelman's Engage 2.0, a 5-day webinar series covering a broad spectrum of topics related to the steel sector. On behalf of Steelmint, I would like to extend sincere thanks to the Ministry of Steel and Indian Steel Association for supporting the event. Also, I would like to take this opportunity to thank our esteemed sponsors, NMDC and JSW Steel. This session is on growing importance of pellet feed in India's steelmaking. I am Nishtha Mukherjee, your host for the session. I would now like to welcome our esteemed speaker for this session, Mr. U.S. Ramachandra Raju, Head Pellet Plant Operations at Odisha Asset of ArcelorMittal Nippon Steel India. Mr. Raju has 28 years of experience in construction, commissioning, and operations of beneficiation plants, slurry pipelines, and pellet plants. Welcome, sir. Also, I would now like to invite the co-host of the session, Mr. Nirmalya Dev, Editor Technology, Steelmint. Before I hand over the floor to Mr. Raju, few preliminary remarks from my side. Please allow me to share my screen. I hope my presentation is visible to everyone.
Yeah, it's perfectly visible. Please carry on.
Thank you. So let's have a quick look at the India's pellet industry performance in the last 5 years. Talking about capacity, India's pellet capacity has witnessed a significant growth, roughly from 85 million tons seen in CY 17 and 18 to touching close to 110 million ton marks in CY 21. Similarly, in terms of production, we have seen a significant growth right from 65 million tons in 2017-18 to roughly 75 million tons in calendar year 21, out of which share of exports has been roughly 10 to 13 million tons. Now that's a breakup of how the production has been and divided into the captive and the merchant share. If we talk about India's total pellet production, the share of captive was roughly around 45% and rest 55% was that of merchant. Out of the merchant domestic pellet production, share of sponge iron route was roughly 57% and that to the PF route was 42%. With steel mills showing an increasing propensity towards using pellets in blast furnaces over sinter, and thus we expect India's pellet capacity to increase in the coming years. So that was a short presentation from my end. I would now request the attendees to put in their questions that they feel they want to ask in the chat box. Now, let me turn towards our esteemed speaker. I would now request Mr. Raju to share his insights. Over to you, sir.
Thank you, madam. You're able to hear me?
Yes, sir.
Thank you. Good afternoon to all. I'll just go into my topic. I'll share my screen. Is it visible?
Not yet, sir.
Madam, is it visible now?
No, sir. Should I try presenting it from my end?
Yeah, no problem.
Sure. Just give me a second. run up. Is it visible now, sir?
Yeah, it is visible.
Sure, sir. You may go ahead now.
Okay. So this growing importance of pellet plate in India steel making. Next slide, ma'am. These are the index. So I would like to go into synopsis. What is the crude steel production, finished product consumption, and government framework and opportunities for steel industries. Then I want to go into the main subject, that pelletization, then issues and concerns, and support and way forward. So these are the topics I'm going to cover. Next slide, madam. This is the crude steel production at a glance. So the world's crude steel production from 1950 to 2021, you can see the vast improvement, because by initially for 10 years there used to be growth. Now we can see in 1 year itself that much growth has come, and it is rising. And you can see last year to this year, it is almost 73 million tons improvement is there than the last year production. And the same Indian crude steel production also has gone up from 99.6 to almost 118 crude steel production last 2021, 22-21. Next. And the finished product consumption pattern, like India per capita, 2010 it was 51.7 kgs, and it has come to 69 kgs now. And further it is expected to go up to 160 kgs. And this is the Government of India framework to boost steel sector. So government has recently rolled out 3 national landmark policies, that is National Steel Policy 2017, and Policy on Preference to Domestically Manufactured Iron and Steel Products, and Steel Scrap Recycling Policy. The principal objective of National Steel Policy 2017, build a globally competitive industry with a crude steel capacity of 300 million tons by 2030-31. So increase per capita steel consumption to 160 kgs by 2030 and 31. So to domestically meet entire demand of high-grade automotive steel, the electrical steel, special steels and alloys for strategic applications by 2030 and 31. So increase the domestic availability of washed coking coal so as to reduce the import dependence on coking coal to 50% by 2030-31. So to be net exporter of steel by 25-26. So encourage industry to be a world leader in energy and raw material efficient steel production by 2030-31. So in a safe, sustainable manner, and develop and implement standards for domestic steel products. So continuation to that, under DMI and SP GOI mandates, as per the government notifications, amendment in May 2019, a policy for providing preference to domestically manufactured iron and steel products and minimum of 15 to 50% value addition in government procurement as per the policy mandate. The policy encourages the downstream companies to set up capacities for steel products which were otherwise directly imported in the past, leading to sustainable outflow of valuable forex. So applicable for all the projects and procurements where the aggregated estimated value of the iron steel products is either 50 crore or more. So the policy emphasized to promote growth and development of domestic steel industry and reduce the inclination to use low quality and low cost unfairly traded imported steel in government funded projects. So opportunities for steel industries. So Indian steel sector has incredibly good long-term growth prospects backed by the government's aspiration to double the installed capacity to 300 million ton from about 140 million ton, which is there now. It is indeed a big challenge to build such a capacity by 2030. But a lot of scope is there for expansion as the Indian market is growing. And all the steel giants have high ambitions to grow in India, which is reflected through the expansion plans. Today's business challenge have revolved around on the way to improve production while reducing the cost, and quality enhancement and equipment improvement process is the requirement. Coming to the pelletization, global iron pellets market is projected from period 21 to 27. So key takeaways from iron ore pellets market survey: with massive steel production, China will continue to dominate the iron ore pellets market around East Asia during the forecast period. So based on the source, the blast furnace grade is anticipated to dominate the market during the forecast period, expanding at a healthy CAGR of 5.6%. The magnetite remains the most preferred source for manufacturing iron ore pellets due to its high iron content, creating incremental dollar opportunity of US $1.2 billion by 2021 end. So key drivers: depletion of high-grade ore reserves is positively impacting the growth of iron pellet market. The various advantages associated with iron ore pellets, such as higher iron content and eco-friendly nature, fosters their demand across various industries. Increasing the vehicle production and rise in construction activities will continue to fuel the demand for iron ore pellets during the forecast period. The fluctuations in the price of raw material can be a restraining factor for the iron ore pellets market. Agglomeration. So initially we started with cold briquette, sinter. Now pellets has become a priority now. The conservation of mineral by use of fines, ultra fines to agglomerate, making it usable in the steel industry. The iron ore pellets have aesthetic advantage over others due to the virtue of better shape and strength. And this has only made it possible in utilization of iron ore fines, but also transport to longer distance. The advantages of pelletization is the utilization of waste ore and lean ores as cheaper and abundant raw materials, and higher tumbling index and lower abrasion index, good porosity, choice of size, built-in flux, and higher bulk density compared to sinter, and improved productivity. The highlights of iron ore pellets in the steel industry. Iron ore pellets is widely favored by steel industry in various countries. It has the following highlights. So it has the low production energy consumption, suitable for large scale production. The uniform particle size ensures good air permeability of blast furnace burden. So it is high voltage and widage and good reducibility, which is beneficial to improve the utilization of chemical energy of coal gas. Its cold intensity, compression and wear resistance is high, so that it is easy to transport and store with small dust content. Iron ore pellet features high iron grade. High grade increases the effective weight of the burden column and reduces the coke ratio. So why we need iron ore pelletization plant? So with decrease of high grade iron ore, we gradually pay attention to its recycling and meanwhile increase the utilization of low grade iron ore. So iron ore pelletizing plants play an important role in these two aspects. For low grade iron ore, they should be a beneficiator to improve the iron content, and we usually grind up iron ore after mining and remove the gangue part, that is as tailings. So therefore, most of the iron ore that is sent into the steel plant has a fine particle size. So iron making blast furnace requires high air mobility during operation, so that iron ore fines should be processed into the iron ore pellets in the iron ore pelletizing plant in advance. So during the process of high grade iron ores, which don't need beneficiation, many ore fines are generated, which are usually regarded as waste. So in iron ore pelletizing plants, these iron ore fines can be recycled, pelletized for steel making instead of being disposed of. The advanced production technology and automatic production process, iron ore pelletizing plants meet the needs of various steel enterprises. The iron ore pellets produced by its feature iron ore content, uniform specification, which effectively improve the production efficiency. The pellet performance in BF and DRI. See, in AMNS gas-based DRI and blast furnace, where it is using pellets as feed material, and utilization of percentage in blast furnace is 60 to 70% of pellet feed. Earlier it is 20 to 30%. So that much improvement has come by using the pellets as a feed, and utilization of even DRI, that is 100% with pellet feed now. Earlier it is only 10 to 20%. So that much growth has come in pellet requirement for steel industry. So this is what we have taken from Hazira plant, and the input feed quality what we are getting 63.5 Fe and 100% kiln feed, and pellet feed is 1.33, and yield is around 75%, and Fe is around 77%, and metallization is 92%. And for DRI pellet, what we are producing in Vizag, that is 66% Fe, and kiln feed is now 100%, and pellet feed to our DRI is 1.21, and yield is 85%, and Fe is 88%, and metallization is 94%. So this much improvement has come in that. And even the coal-based DRI has adopted iron ore pellets as their feed burden and comfortably converted 100% usage as a feedstock. So typical quality comparison with pellets and CLO in a 300 TPD DRI kiln is as follows. Pellets of 63.5 Fe and 100% feed, and pellet feed and DRI is 1.47, yield is 67%, and Fe is 78%, and metallization is 89%. And CLO is 66% Fe, but kiln feed is 100%, and pellet feed is 1.55, and yield is 64%, and Fe percentage is 83%, and metallization is 88%. So we are getting a better metallization with pellets. And issues and concern in the pellet plant. Now capacity utilization is a point now, because we have large capacity and also a lot of pellet plants are coming. And because of variation in pellet feed, so the production capacity of pellets you can see up to last year. So only 78% we are utilizing the pellet capacity, because we have to improve on that. Now, if you can see our design and operation parameters for our DR grade and our BF grade. So DR grade we are producing from Kirandul in Visakhapatnam, and BF grade is Odisha asset. So you can see the changes what we have seen, like Vizag it was designed at 67 DR grade, but now we are comfortably running at 65.2 because of poor quality availability. The same BF grade what we are producing here, designed for 64, but right now we are getting less than 62. And the input concentrate LY also 0.9 in a DR, and we are getting now greater than 2.2. And BF grade it is 3.5, and it is greater than 3.5 now. And the CCS which we used to get 280, now we have come down to 260 because of grade in DR pellet. And now it BF grade it has come from 250 to 230. And the tumble index which was 95, it has come to 93.5 now. And the BF grade is 94 designed, but we are getting at 92.5 with high alumina, whatever we are the material we are getting right now. See, this is our DR concentrate and product quality. If you see, we started 4 years back at 66.24 concentrate from Kirandul, and now it has come down to 65.2. So that much variation, and is year by year it is coming down. So that is a challenge now. And the silica also, which is at 2, has gone to 3.26, and alumina, which was 0.84, always it is less than 1. Now it has gone above 1 for DR grade. And even LOI, which was at 2.15, it has gone to 2.54. So it has gone to the peak again. And pellet Fe, 66.04 or 4 years back, now it is 65.38. And filter cake moisture, also 10.47, 10.29. But again, suddenly it has gone to 10.5 because of alumina going up in 2020, 2.54 in DR grade pellet. So this is a depletion of grade, the iron ore fines, and this is how we are managing. I'll show in the further slide. Now this is the BF concentrate, what we are getting from Dabna. It is started with 64.11, we have gone up to 64.33, 2019, now it has come down to 62.41. And the same silica has gone up to 4.55. Now alumni we are touching 2.67, and LOI is gone to 3.23, and now it is to 3.14. And if you see pellet Fe from 64.67, we have gone to 64.79, and now 64.3 and 63.01. The presently what we are producing. So this is the grade which is falling, and further. So these are the challenges at pellet plant now, as the grade is coming down, and now whatever material it is designed, and further day by day year by year it is going down. So our challenges are excess gang and particle size. That is the main problem which is causing a filtration problem, and uncontrolled growth and plastic and deformed green balls. Next is variation in size and increased recycle load. The recycling of green balling has gone high. That is another challenge, and increased LOI and dimensional limitation of furnace. So seeing Vizag DR grade and whatever LOI we are having, Paradip we have increased the furnace length to handle this LOI, but still the LOI further increasing beyond 3.3 at Paradip now we upgrade. So now coming to transportation, degeneration during transit is another issue, challenges for pellet plant. Now impact on pellet plant operations, the increase in moisture levels due to this gang having more gang, alumina is high, and inadequate filtration equipment with respect to deterioration in iron ore, and difficulty in green ball pelletizing, because either it will become a small size or suddenly the size grows and it will become oversized. So there is a difficulty in controlling the ball size in green ball, and cracks generation and improper firing. That is another issue. And pellet quality deterioration and degradation of pellets, and process difficulty and limitation on production rate, and increased resource in transport and rejects during iron making. To overcome this, the enablers, what we are saying is that the changing over from conventional filtration system to advanced filtration to handle variations in the input material, and use of organic binders to help improve balling, low grade, and to reduce moistures. And next is automation in balling will help in better control and reduce size variation in green balls, resulting in better pellet generation and layered screening. Coming to furnace changes, plant audits to modify heat treatments, gas flows without major dimensional changes is an option. Next. Now we have changed over from vacuum disc filters to pressure filtration. So to handle this issue, so now pressure filters are coming to line, and we are able to manage total BF grade pellets what we are producing through slurry pipeline pumping from Dobna. So the pressure filters have come to our rescue, and we are able to operate at the required moisture with the pressure filters, and with that we could come out of the moisture problem. But still they are maintaining high, but we are having a ways and means to do better. So further I can explain in detail. See, what we have done is, for each pelletizing disc, we have put a single deck roller screen. So instead of having 10-12 discs and all recycle going and now choking at the feed end of the furnace, that is having a common double deck screen. So what we have done is started doing screening at each disc level itself with a single deck of 40 rollers, so that we can remove fines and we can have correct size on the product conveyor and the feed conveyor, then rejects oversize which are going back to recycling. So the initial discharge itself we are doing a screening, so that the load at the furnace will come down, feed point of the furnace, where we are having a double deck roller. So this is one change we have done in the existing plant at Odisha Paradip. So this is having a good advantage in handling this with bad material. And one more change what we have done, there what we have double deck initially, now in the second plant we have put double deck roller feeder, that is with segregation. So we are doing double layer. So it is having a 2 layer, from bottom layer is 8 to 12 mm, and the top layer is 12 to 18 mm, means 12 to 16, whatever it comes, it goes to the top layer only. So advantage by having a 2 layered pellets, because when it takes heat from the top to bottom, the bigger size will see the direct heat from the burners, and the bottom will take the heat. So advantage, the thorough good firing and permeability improves, and we have seen the burn through. There's a lot of improvement after installing this in the second plant compared to the plant 1. One is the permeability has improved. You can see by windbox pressures, they have come down. And add to that, the power also, the process fans power has come down by 4 kilowatt per ton. That's a good saving. And burn through also, we are getting at lesser fan openings. That is the advantage with lesser fan speed. So there's a lot of improvement with this in the second plant compared to plant 1, which is having a double deck roller scheme. So that we are planning to change in the next shutdown for the segregation feed. So this is helping a lot in our this material, PF grade material, what we are getting from Dopna. Now another is the like achieving necessary adjustment in gas flow by adopting modifications suggested by OEM. And that is one we have taken up wherever it is required. If there is a higher LOI or more silica, whatever it is coming, we are just changing, taking the OEM's help. We are modifying according to that. Every shutdown, we are making some improvements so that we'll be able to whatever iron ore changes are there that we want to solve ourselves with the help of OEM. Like furnace simulation also models developed by R&D team and for adjusting the temperatures as per the processing material. So that is also internally developed and we are managing with that. Support and way forward. Support needed in adopting the agglomeration process. The government mandate for installation of beneficiation plants for all ISPs in the country and the captive mine owners insists guaranteed usage of low-grade ore in steel making and support industries with necessary lands for tailing storage. So that has become a big bottleneck for rejecting the required tails percentage when we are doing beneficiation, and encourage new technologies in improving beneficiation process efficiencies. The fund government institutions in the providing new technological solutions in coordination with the operating plants and considering the volume of fines requirement in the future and its suitable usage in steel making, like beneficiation process with downstream processes like slurry pipeline and pelletizing process is going to be a vital requirement in iron and steel industry. And single window clearances for all the new projects and special subsidies and faster ROW clearances for adopting the slurry pipeline technologies which are environmentally friendly and safe process. So this is the way forward for 300 TPA. So expanding the resource base for processing the low grade and the sustaining growth rate to enhance the demand. Then increased focus on R&D for low grade utilization. This is very important, R&D, and create the focused groups and national and international collaboration and support installed facilities to run at full capacities for expansion. And for way forward, what I can say is capacity utilization of pellet plants is very important because to bring down the specs, so this will be very useful. So that is the first challenge, and the design advances to factor the deteriorating ore quality. See, already the slurry pipeline is running with full automation. So normally we give a set point and only one person will be there for just monitoring. Otherwise, no man is required in the control room. That's advantage of the slurry pipeline. Like beneficiation plant also, we are making a lot of automation there so that to reduce the manning in the beneficiation plant. And at the like R&D process, also R&D and automation, wherever it is possible, we are making it automation so that it will be user friendly and it will be advantage in maintaining the sustainable production and quality also in the process, and increase pellet usage in the steel making. So that also, the better the pellet we make, so we can have a good consumption in the steel making process. Thank you. So any questions?
Thank you so much, Mr. Raju. That was really a detailed presentation. Before we go on to the audience questions, one question from my end. Any rough estimate that you would like to suggest that which all pellet capacities do you expect to see ramping up in this calendar year?
In this calendar year, I can say from AMNS side, we are going with another 2 pellet plants, 6 million. Right now, 6 million, one we have already started. So means land filling and all is going on. So we require for ourselves in Hazira because there we are expanding. Right now, we are producing 7.2 million. So we are going up to 14 million by 2026. And by 2030, we'll be reaching 18 million. And added to here, we are also putting up 12 million steel plant in Kendrapada. So there also we require pellets for that process. So that is how we are planning to go with 30 million pipeline from Dabuna to Paradip. Right now we are operating 12, so we are going with the 30 million pipeline. So that is how it is. And I'm thinking like many are coming now, like Runta is commissioning the plants. So many other JSW also commissioning the plant. So I think this year also, like last year, 20 million can add to 2022.
Thank you, sir. Over to you, Nirmalya, sir, for the audience Q&A. Sir, I think you are on mute. You need to unmute yourself.
I'm very sorry. Yes. Am I audible?
Yes,
Yeah,
you are.
Yeah. Thank you, sir. Thank you. And welcome, Mr. Raju. Very good afternoon, sir. Actually, before I go to questions that have been posed by members of the audience, I would like to ask one question myself.
Yeah.
So as far as India's predominantly blast furnace steelmaking infrastructure. So, sir, my question to you is, what could be the total, ferrous burden of pellets for the current blast furnaces that are there in India? So, how can the pellet burden be improved in the blast furnace?
This pellet burden, in our case, how we are doing, I can explain clearly. See, we are having a DR grade and we are having the BF grade also. So normally when quality is good, when the grade is good, BF only we used to feed. Almost we have gone 70, minimum we are maintaining. Sometimes we are going to 100% also. But right now when it is depleting, we are using the mix of DR and BF so that we can have maximum pellet feed into the blast furnace. So now we are looking for option to go for DR grade pellets so that whenever there is a low grade of BF, we can still mix some percentage of DR and we can utilize for maximum utilization of the steel plant.
And sir, what is the kind of tumbler index that you prefer for feeding into BF?
The 93.
Sir, and sir, about the permeability in BF for pellets and compared to lumps. Sir, what is your viewpoint? Like currently, sir, if you talk about permeability, then which one is more efficient in terms of for the blast furnace steel makers in India?
Yes, this same blast furnace in Hazira we made a record that if you see that time they were feeding 100% blast furnace from Odisha only. So I can still say proudly that pellets has given a good productivity in the blast furnace because it is proven in our plant, and because of that now a lot of pressure has come to Odisha, and I was telling you that we are putting more pellet plants in Odisha because of the same reason. People were thinking that here grade is low, it is very difficult because when I was in DR grade in Vizag, so people will think DR grade is the only pellet feed we can do. Now when this BF grade has come, and that too in a blast furnace, as I said, 100% pellet feed was there when they produced 7,100 from 4,500 meter cube blast furnace. So 7,100 is a record till now for highest, and we could do it with Odisha pellet. That is all because of mobility, coke ratio, and that less. So that's how they could make it.
Yes, sir. A very insightful answer. Yes, sir. Actually, I was also wondering about one thing before I go to the questions that have been posed by the by members of the audience. Sir, we were also talking about scrap feed in blast furnaces. In China mainly, where they're trying to use this scrap feed in blast furnaces. So, how do you see? I mean, what could be the total volume of the total percentage of ferrous feed, the burden in the blast furnace? So, how much can scrap go considering the current design and engineering pattern of Indian blast furnaces?
No, right now that data I'm not having. I can share with you later because I was not having that. What was the design? But normally, see when the pellets we are able to get, the pellets ratio we are increasing because we have now sufficient pellets with us. So that right now, because when we have commissioned the second plant, we are able to produce almost 11 million, and we are sending to Hazira. And we also, after having our own requirement, we are selling outside in the market also. There's a lot of demand now. It is going on like that. But what you asked, the figure I'm not having right now. I'll share with you.
Correct, sir. And sir, how much is AMNS thinking of converting now that pellet capacity is going up really rapidly for AMNS? So what kind of pellet feed will be provided to for DRI maybe in the coming time, for DRI and maybe also gas-based DRI in the coming time?
Gas-based DRI we are using 100% anyway. It is going, and we have already 8 million DRI pellet, and we have this 12 million blast furnace is there. But the DR we want to go another 6 million. We were trying for that, and another 12 million for blast furnace. So that is our estimation for next 3 years. We have to make that.
And so the short-term estimation, that's the last question from me. The short-term estimation about reducing the content of coke in blast furnace steel making by providing more of pellets and more of DRI and more of scrap. So if you just could give, I'm not asking you a final question, just a small, question, just a small kind of estimation for the coming 10 years as to how much CO2 we can reduce per ton of hot metal, by providing more pellets and more scrap and more DRI.
No, what actually we were trying is, so as I said initially, pellet were increasing, and added the better coke we use, it is always is better, because we have tried with Indian coke, then we are having a problem. Then we are importing Poland coke, that is giving a good results for us. So there's a lot of difference. So that quality of coke is also very important. So that it matters a lot in the blast furnace.
Yes, sir. And so we have a question from the audience, an interesting question that I want to put forward to you. I don't see the name here. What is the highest quality of pellets that can be produced, and which company in India has capability to produce high-grade pellets?
We have 66, what we have produced in 66.2, we have produced already. See, there also the economics will come, because I have seen you can produce high grade by buying the ore iron of higher grade material. The problem is, and at the same time, if I do beneficiation, I can do still better. But if you see the resource cost, means iron ore cost, and when we have capacity in Kirandul to throw 20% reject, I used to get even 67 concentrate. But we are not going to that, it is not economical. So we have to see the economics also. So that is how we are restricting now 66.2, we are calling as a DR grade. Initially, 67 is DR grade. So we have come down on that. At the same time, we are seeing the cost economics and we are producing it. Because when the ore becomes so costly, so rejecting is also becoming a problem. So we are optimizing, and today we are operating at 65.8 because of the same reason. So we are trying to do only slight beneficiation. We are not doing 100% beneficiation. In Odisha also, we have capability to 30% reject, because we have a tailing dam issue. But further, with the small deslamming, we are getting the required quality and we are producing the maximum volume.
Yes, sir. And sir, one other pertinent question, of course, not directly related to technology and the use of pellets in metallurgy, but a general market question that has been put forward by one of our participants. What is the export outlook going forward for pellets, of course, for Indian mills, for Indian producers?
It is fluctuating with the rate and all, if you see, because if you see last month, we have done almost 5.1 million send our pellets. So that is there always. Like last month we have done, 5.1 lakhs we have done. So this month also we are targeting 5.5. So it is increasing month by month, because we have other pellets. So we are also exporting. That way it is helping us. And I think the demand is there. When the quality is proven, the pellet quality is consistent, there are many people who are taking the pellets now. And even we are sending our own pellets to our Europe plant. It is like that. So we are sending to Europe plant. Now 2 shipments have gone to Europe. China also we are selling. So it is going on like that. Good demand is there. Market demand is there.
Yes, sir. And one very generalized question that has come from a participant, that if India is making 300 million tons of steel, if not in 2030, maybe sometime later, how much of pellet would be required to make that steel?
So it will be, if you ask me, it is almost 1.6 times we can take.
So what could be the production, sir? Just just an estimate. Yes. So considering that we are producing about 250 to 60 million tons of steel.
Yeah, it will be, you can take around the same quantity we can take, if you ask me. Now we are at 100, it will go up to like 300 million we have to do. At least 1.1 times it will be there.
That increase will be there.
Yes.
Yes. So that is a very good. Thank you so much, sir, for that insight. Yeah, Nishaji, I will request you to carry on with questions if there are any.
Sure. Well, I think that was the last question that we could accommodate for this afternoon. Due to time constraints, we have to bring this webinar to a close. Again, a big thank you to our speaker and viewers for joining in. And we do hope that you all enjoyed the session and it was insightful for you. Also, we would like to extend our gratitude to our supporting associations, ISA and Ministry of Steel, and also our sponsors, NMDC and JSW Steel.